All right, this is the third part of stoichiometry, and in this portion we're going to look at some of the shortened versions of the stoichiometric process. In the previous screencast, you've watched about changing from moles of one substance to moles of another substance, and changing from grams of one substance into grams of another substance. Well, sometimes in this process you don't have to go the whole way through, and we could be either giving you the number of moles and you change to grams. So you would start here with moles and change it to something else using the mole ratio and changing it out to the molar mass to find the grams. Or you could be looking at starting with grams and finding the number of moles. It's the same order of operations, it's just starting and stopping at different places. Alright, so here's a sample problem. You have 6 CO2 and 6 H2O makes C6H12O6 and 6O2. So it says what mass in grams of glucose is produced when 3 moles of water react with carbon dioxide. Okay, so we have a balanced equation, that's good, so we can find our mole ratios. We're being asked to find the grams of glucose and we are given 3 moles of water. So we're starting with moles and we're changing to grams. So we have 3 moles of H2O, which means we have moles. We can now use the mole ratio and go straight to moles of our other substance, glucose. And then we can use our mole ratio and set up the fractions. So let's put moles of H2O on the bottom, and we're going to put moles of glucose on the top. And you can see that you have 6 moles of H2O, and you have 1 mole of glucose, so that would look like this, and that is your mole ratio. And then you're going to change from moles of glucose into grams using the molar mass. So we're finished because we have the unit that we were asked to find, which is grams of glucose. This one is only 2 fractions because we started with moles and we're ending with grams, and we have an answer of 90 grams of C6H12O6. So this problem is saying if we took 3 moles of water, how many grams of glucose could we make? We use the mole ratio and we use the molar mass. Alright, here's another problem using the same chemical equation. We're given that we have 25 grams of oxygen and we want to know how many moles of carbon dioxide would we need. So in this case we're starting with grams and we're going to moles. So in the first fraction we have to have grams on the bottom, and then we could change it to mole. So grams to mole is the molar mass, and there's 32 grams in 1 mole. And then on the bottom of the next fraction we have moles of O2, and we can go from moles of O2 into moles of anything in that chemical equation, in which case we are looking for CO2. So we see that there is 6 moles of O2 and we see that there are 6 moles of CO2, and that's our mole ratio. So when you're doing the math on this one, you take 25 divided by 32 times 6 divided by 6. You could recognize that the 6 over 6 would reduce down to 1s and not do it, and that's up to you. But you do have to divide the 25 by the 32 to get an answer of 0.78 moles of CO2. Alright, so you have another sample problem here. It says the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. That's a lot of big words. Basically what they're saying is the first step is you react ammonia. So they've given you a chemical equation. NH3 plus O2 makes NO2 and H2O, and it is unbalanced. That wasn't very nice. Alright, and they say the reaction is run using 824 grams of NH3 and excess oxygen. When they tell you that you have excess of something, they're telling you that you have more than enough to react, and you don't have to worry about running out of it. So the question is, these 824 grams of NH3, how many moles of NO can we form, and how many moles of H2O can we form? So let's start the problem. We have to start the problem by balancing the equation, and you have 4 NH3 is 5 O2, and 4 NO and 6 H2O, and you would take the 824 grams NH3 and you would first convert it to moles of NO, and then you would convert it to moles of H2O. And you can see the process that we've gone through here. The first one is changing from grams to moles. And then once we have moles of NH3, we can use our balance equation and change it to moles of anything else. So you've done that same first fraction in both problems. So on the next fraction, you have moles of NH4 on the bottom in both cases. And on the top, you have moles of whatever substance you were looking for. In this line, it's moles of NO. And on this line, it's moles of H2O. So we have our molar mass and our mole ratio. and we got two different answers.